Hey, what's up, guys? I'm Pugar. So, today we are going to look into a new chapter. It's not a new chapter. So, it's the first chapter in Form 4. So, it's known as the chapter 1, which is measurement. Now, I'm going to teach you guys what is the best way to study this. It's not of like not me teaching, it's sort of like me trying to share my experience on like how much I loved physics and the way I learned it and the way to sort of like look the world of physics, and also like the easiest way to read, to understand all of these chapters. So yeah, I'm really happy that you guys sort of like see this journey. So let's see where it goes. So yeah, let's look into it. Now I have three most important questions which is asked in the textbooks, so you can take a look into that. So the three main reasons that you're studying this, or like getting to know about this chapter, is first, what are the physical quantities? Second, how to form derived quantities, okay? Derived quantities using base quantities and its respectful units. Now, the third thing is the importance of the skill in interpreting and analyzing the graph. It's very easy, so let's get right in. So, there are two types of physical quantities. First is base quantity. So, we use base quantities. There are a couple of like examples that you need to know, but for example, we look into base quantities, and also like the another one which is known as the derived quantities. So it's derived quantities. If you don't know what this means, it's totally fine, because we are going to learn it together. Now, base quantities and derived quantities means, or sort of like, the physical quantities that we use to do accurate measurements of something. So for example, let's take a look into base quantities. Base quantities has a lot, has a lot of examples which we will look into later, and also derived quantities. The main difference, or like sort of you to understand, is base quantities doesn't need any sort of a formula, any sort of like a technique to get the answer. You can just look at it and you can just know it. For example, length or distance, you can just look, like for example, you open maps or Waze, you can just see the distance, right? So from my home, from my house to my school, what is the distance? 14 kilometers or miles, or whatever you're using. So it's doesn't need anything else to measure. You only need magnitude and also unit, which we will look into later. But the best thing is, base quantities doesn't need any sort of like formulas, any sort of like extra measurement steps in order for you to get the answer. But derived quantities use some sort of a formula, or like some sort of ways to get the answer, rather than just looking at it and getting the answer. So yeah, that's sort of like the basis of all of this. Now, before going into that, we need to know how to state it. How to state both of these, which is known as physical quantities, is you need to must have the physical quantity. So physical quantity. Now you put an equal sign and you need to write first the magnitude, which is, so the magnitude. So magnitude means the number. Like for example, 100. 100 is a number. 90, 99, 148, or any other numbers that you use, which is known as magnitude. Now, together with the magnitude, you need to add units. Need to add a unit to like the magnitude. Like for example, in the textbook they have given 100 as a magnitude, and also meter. Now meter means something, right? So meter is the unit used to measure the distance. So to state a physical quantity, it can be a derived or a base quantity. The importance is you need to state the magnitude and also the unit. You can't miss out both. Okay, if it has a unit, you must mention it. If it doesn't have a unit, and you don't have to mention it. It's usually asked in objective questions in SPM. So if you're like wondering where will they ask this, they will ask this in usually objective questions, which is very easy to understand. Now the question is, okay, before we go into these sort of examples of this, okay, which is pretty easy, just stay with me. We need to know one important thing before that, which is the units. Now across the world, units may change. Actually it will change. Okay, for example, let's say you have a ruler. Now on your ruler you have two sides. Two opposite sides have different measurements and unit, which is for pretty easy ones. First is centimeter. Centimeter, and also in the opposite you have inch. Now why there are two units in a ruler? Like you only use centimeter if you're living in Malaysia and all the other countries, but Americans, or as far as I know, Americans are the only one who use inch. I may be wrong, so yeah, if that's wrong, forget me. But mostly you need to know is centimeter. We use it every day on our lives if you're living in Malaysia and also Thailand or whatever the country may be, and you use inch in some other countries. Now why? The unit for centimeter is cm. For inch it's inch. Now why there's different units? What you need to know is, first, centimeter is known as metric units. All right, metric units. It's used across the world. Most of the countries use metric units. Another example for metric units is Celsius. Now inch, okay, inch means it is a imperial unit. It is known as the imperial unit. Now imperial unit, another, like the opposite for Celsius is Fahrenheit, right? It's not the opposite, but you get the point. So people use Celsius and also Fahrenheit. Why they use different measurements? Different units. Why? Because they use different sort of, like, one use metric units, one use imperial units. So you need to know this. If they ask you, like, is this imperial units or metric units, so you need to know it. Okay, so most of the things that we use in Malaysia, almost like 99%, we use metric units. Okay, only a few things we may use, like inches or psi, for example. So all of those are imperial units. So don't get confused. Units are different types. Some country use metric, some country use imperial units. You don't need to memorize any of this, just know it. Let's go into the next one, which I've been teasing all this video, which is base quantity and derived quantities examples. All right, there are 7 that have been given in your textbook. So let's look the 5 first, and also this, like the other 2. Now first, base quantities are 7 in the textbook. First is length. Now length is, you all know what is length is. Now the symbol for length is L. It's pretty easy. L, length. So for mass we use M, mass. So time is T, and also thermodynamics, temperature. So we use a capital T, and also electric current we use I. Now what are these? These are the symbols used to showcase different types of this, like length, mass, time, thermodynamics, temperature, we use the capital T, and also the electric current we use I. Now these are the symbols used to to showcase. Like for example, when you're using a formula, you need to know what are you putting in order to get the answer. Now we know these are the base quantities, and these are the symbols for those base quantities. Now we need to know the SI unit. Now SI unit, okay, I'll write it now. SI units. Okay, so for length we use not L. So for the SI unit we use Meter. That's it. Meter is the SI unit. Now the symbol to represent meter is pretty easy. M. So this is the standard, which means you can use kilometers, or actually not kilometers, sorry. So you can use centimeters or inches, for example, but for across the world, you don't need confusion when you, like, for example, doing an experiment, or like doing collecting a data or something like that. You need to read it across the world. You don't need confusion and also the conversion error, sort of like that. So to avoid that, all the countries have agreed to use SI units, which is known as, standardized, international standard units. So meter is the SI unit and the symbol is M. Now for mass, it's kilogram. I mean, it's pretty easy. So kilogram is used, pretty much everywhere in Malaysia. So kg is the symbol for kilogram. Now to represent time, it's in second. So second is pretty straightforward. It's an S. For thermodynamics temperature, this we use Kelvin. Kelvin is the standard, so that you won't get confused. Some use Celsius, but you use Fahrenheit, so you don't know like what does it actually mean. So to avoid that, they all use Kelvin to sort of like standardize and understand what the other people is trying to convey. So Kelvin is a K, okay, so capital K. You will read more about this and the usage of this in the 4th chapter. So electric current. Electric current is ampere. So ampere uses, A. You can see this pretty much everywhere on your phone's charger brick, or like for example in the TV and all the electronics. You can pretty much see the symbol A together with I and also V. Okay, so yeah, these are the things. For length, this is the base quantities: length, mass, time, thermodynamic temperature, and also the electric current. The symbols are pretty straightforward. Now for SI units and its symbol, for length it's meter, M. I mean, you don't really need to memorize it, okay, so you can just straight away write it. Now the other two is luminous intensity and also amount of substance. All right, so for luminous intensity, there's this is the base quantity, and for that base quantity there is a symbol. Of course, for amount of substance there is also a symbol. So for luminous intensity, we use I capital with a V down below. All right, that's how we write it. This is the symbol for luminous intensity. So for amount of substance, we use N. N. Now amount of substance is pretty easy to memorize because you will always use this in chemistry. So when you're learning the 3rd chapter in chemistry, you can just know, okay, amount of substance, it's N, and also the SI unit for it. It's pretty straightforward. Now let's look into luminous intensity. This is the symbol for base quantity. For SI units, so we use known as chandela. I mean, I really don't know how to pronounce it. I mean, I've seen quite a few like chandela, candela, sort of a thing. So you can search it and put it down below how to pronounce it. I mean, do it. So okay, let's call it chandela. I don't really know. I haven't done research on how to do like pronounce it. So for the sake of simplicity, I'll use chandela because it's pretty easy to like sort of spell it out. And also the unit used is CD. I mean, it's pretty straightforward. C and D, CD. For amount of substance, it's pretty easy. It's mole. Mole. This is the SI unit. Now the symbol is MOL without the E. Now this is all that is. Don't try to memorize it, sort of understand. Do like a 5 or 10 questions or maybe 15 questions related to this subject or this chapter. especially for this base quantity and also derived quantity, you can just sort of get the idea and sort of automatically memorize these SI units. Now let's go and take a look into derived quantities and what it means. Now there are only 4 examples that you need to know and sort of memorize if you want to, but try to understand it. Now the first thing is volume, the second thing is density, and also velocity and charge. Now there are no like SI units for derived quantities, so there's less to memorize or less to understand if you like and try to understand rather than memorizing. All right, now let's take a look into volume. Now the symbol for volume is V. Okay, it's a capital V, so keep that in mind. Okay, you will use it regularly after this, so you don't need to worry about it. So after a few uses, you will just V, it's capital V. For velocity, you say like a small v. So now let's go into the formula. Now derived quantities, as I mentioned earlier, only, so you need to create a formula using base quantities to get derived quantities. So without those formulas, you can't get derived quantities. All right, now let's look into this. Now in order for us to like find volume, look at this formula. It's length, L times length times length. As we all know, length is a base quantity. What are we using here? We are using 3 base quantities to get V, volume, which is a derived quantity. So yeah, this is the formula. V, volume equals to length times length, or length to the power of 3. So this is pretty straightforward, very easy. You've learned it in mathematics, so it's not a big deal, to memorize, and so it's pretty easy. Now let's go into density. Now the symbol, it's kind of like a P, but it's not fully a P, so it's a small p. So yeah, you can just take a look at it and you just know. I don't really do the research on what it's called. So if you know that, or do a research and comment it down below so we all can know it. All right, now the formula to find density is mass over volume. It's a capital V. So mass, what is mass? It's a base quantity. And what is volume? So volume is a derived quantity. Whatever it is, we are still using mass. Now you might say, I mean, we are using a derived quantity, so does that mean we can like get a new derived quantity from another derived quantity? Now where do you get this volume? I mean, mass, it's kilogram. Now what is volume? Where did you get that volume? From using base quantities. So you can also write it like L to the power of 3, but nobody wants this. I mean, you can just, what does that mean? It means volume. So that's why we don't use like L to the power of 3. Instead we are using volume because it's pretty easy this way rather than writing it, as I showed it earlier. So hope you guys get the point. Now let's go to velocity. We use a small v, and the formula for that is also from base quantities, length over time, T capital. Remember, time, the unit SI for that is second with an S, okay, as its symbol. Now for charge, we use Q, okay. Don't ask me why. Do research and comment it down below so we all can learn. All right, Q equals to I, okay, the intensity, okay, the electric current, and also like times with time, okay. So T means time. So yeah, electric current times time, we get the charge of something. So this is derived quantities. There are only 4 things that you need to know that can be asked in your SPM exam. Now let's go into the another section. We've learned base quantities and also derived quantities, which are physical quantities. There are also 2 other quantities that you need to know, which are very, very simple. All right, first is scalar quantity and also vector quantity. Now what does this mean? It's actually pretty easy. Now scalar quantity means it only has magnitude. It only has magnitude, which means it only has its number, like 100 kilometers, like 10 seconds, sort of like that. Now, vector quantities have magnitude. I mean, all like physical quantities must have a magnitude, but vector quantity also has direction. So that is what you need to know. All right. So scalar quantities only like used for scaling. So scalar quantities, so it only has magnitude. Vector quantities means it has magnitude together with direction. All right. So let's take a look into, like, for example, the scalar quantities and also the vector quantities and the examples for it. All right. In your textbook, there are 10 examples for scalar quantity, and also vector quantity, there are 5 examples. Now, do you really need to memorize everything? I mean, you really don't, because you need to understand. If you understand, when the question is there, you can just sort of think, okay, does this require direction in order for us to do the calculation or something like that? Does it need it? So let's take a look. So for scalar quantity, let me give a few examples. Distance. Distance is a scalar quantity. Why? Because let's say, for example, from your home, okay, you need to go to your school. Now, what is the distance between these two objects, these two places? It's, let's say, for example, it's 12 kilometers. Now, does this require a direction? I mean, if you want to go, like, okay, go there, go straight, right, left, I mean, that's a direction. But do we need direction in order to understand this quantity? You don't really need to, right? Why, like, you can just know, okay, it's 12 kilometers. Yeah, I understand. So it's very straightforward. You don't need any direction. All right. Now, what else? Time. Time doesn't need a like a direction. Also, area. I mean, if you're calculating, like a measuring a area of a circle, do you really need to know, okay, in which direction is this area? No, nobody would ask that question. Area means you can just understand, okay, this is the area. All right, I get it. Sort of like that. So scalar quantities doesn't need a direction. It only has magnitude. What else? I mean, temperature. So temperature, I mean 23 degrees Celsius, so you can just pretty much know it. It doesn't have direction, right? Now, what about vector quantities? Okay, if it needs direction, what are the like quantities we use? I mean, for example, velocity need a direction. It acts in a direction. Now, very easy is force. Okay, force is also easy. Like, for example, I have this duster. Now, I'm going to apply a force. Now, I'm applying it. Now, does it have a direction? Like, I'm pushing it to my left, which means the force is acting towards left. So, yeah, force does have a direction and also magnitude. You can calculate the magnitude, right? So yeah, force, usually we use F equals m times a, mass times acceleration. So acceleration also has I don't really need to write it, but acceleration and also quite a few things have direction and also most importantly magnitude. Now we are moving into 1.2, which is known as scientific investigation. Now I'm going to put the graph in the screen, so I'm trying to going to explain it to you. It's very easy. Now let's take a look. Now the first graph, right? You can see the blue line starts from 0.0. All right, it starts from there and it slowly goes up. So the interpretation of graph or the understanding of graph is y is directly proportional to x. That's how you write it. All right, so don't get confused. That's how you write it. Y is directly proportional to x if it starts from 0. All right, the linear equation is y equals mx, which you've probably studied in mathematics. All right, now let's take a look into another graph, the second one. Now, where does it start? Does it start from 0? No, it starts above 0 on the y axis. It can be like at whatever point above 0, right? So what is the interpretation of that graph? It is still increasing, right? It goes up. Now it means y increases linearly with x. The word linear is really important here because it's straight. All right, straight means linear. So y is increasing linearly with x. Now the opposite for this, all right, is above 0 on the y-axis for the third graph. Now what is it's going down, which means, oh okay, it's decreasing. So it's pretty much same, all right, as the second graph, but you need to change the increase to decreasing. So y is decreasing linearly with x. Now the formula and also the gradient of the graph, you all know it, you studied it in mathematics, so I don't really need to go into that as much. Now let's go into the fourth graph. Now in the fourth graph you can see it starts from 0, all right, and it sort of curves, but it still goes up, all right, it's increasing, but it sort of curves, it's not linear. Now what does it mean? It means y increases with x. That's it. It just increases with x. You don't need to write out like linearly, right? Because it's not linear, it's not straight. All right, the fifth graph, it's going down, which means decreasing. So it's pretty straightforward. Y decreases with x. Now the sixth one is, you need to look into it. Now, does it touch the y and the x-axis? No. Or there's also the word or. There's also another graph. Now it touches the 0. Now, does it mean that y is directly proportional to x? No. Because look at the x-axis. It is not x, it's 1 over x. Now, what does this mean? What is the interpretation of this graph? It means y is inversely proportional to x. Inverse means opposite, or it's like, I mean, in Malay we use songsang, so it's inversed. So y is inversely proportional to x, while the first graph is y is directly proportional to x. The main thing is you need to look the x-axis. If it's 1 over x, it's inversely proportional. If it's just x, it's directly proportional. All right, that's it. There's also the analyzing graphs, but it's pretty easy, like the area of the triangle, area of the rectangle. You just need to know like a few things. So if you're wondering, you can also ask your teacher. If you don't understand it, please go ask your teacher, because teacher in your school is the best source of information, best source of knowledge, right? So thank you for watching till this video. I don't know, when I like write it distance, I don't know what I just wrote over there, and also slowly it's going up. Yeah, that's usually the error. So hopefully you get to know something. This very easy chapter, I mean it's very long, it's a very long video for an easy chapter, but hopefully I got to explain every bit of information that you need to understand, rather than memorizing and stressing yourself in physics. Physics is sort of the understanding of matter and also all the things, across the universe there is physics, all right? So hopefully you got something out of this video without wasting your time. Yeah, thanks for clicking on this video. Thank you, Nandri, and I'll catch you guys on the next one. Bye.